Alright, now we're going to do the second problem from the 2014-2015 quiz using Boolean algebra. The first thing to note is we're looking for how many ordered triplets make the Boolean expression true. So the first thing we're going to do, as always, is simplify our expression. This will help you get rid of unnecessary terms so you're not doing extra work. This simplifies to not A not times not B times C plus not B times C plus A, C, not C plus not B times not C plus B not C. This can be simplified further using our special rules. So this term is just 0, as is this one, because nothing can be both itself and not itself. So B times not B is 0, and C times not C is 0. Now we can rewrite our simplified expression to get a fully simplified Boolean expression, which we will then see which order triplets will make it true. So our fully simplified expression is not A times not B times C plus not B times not C plus B times not C. And we're going to be working with this to see which will make it true. Now we're going to use the Broner method to solve the simplified expression and see which will make it true. I'm just going to rewrite our simplified expression from before and then draw in the truth tables for A, B, and C as we've already done. Now our first expression that's not A, B, or C is A naught. Our second term that isn't already on the table is B naught, and just a reminder, A naught and B naught are both true when their original term was false. Then we're going to see when both A naught, B naught, and also C naught are all true to get values for the first expression in our sum for the Boolean algebra. So you look when all three have 1s in their columns, otherwise the value of the term is 0. Now we're going to continue working with our expression to see when not B and not C is true. Now we're going to write a table for not C, which is true whenever C is false. And again, not B, which is true whenever B is false. Now we're going to work with the term not B and not C, which is true only when both not B and not C are true. Again, you can do this by looking at the original B and C and making this one true whenever the first two are false, whichever is easier for you. This set of values corresponds with the second term in our expression, which we're then going to put together with the third and the first to see how many different values for A, B, and C make the full expression true. Now we're going to find values for our final term, B and not C. We already have a table drawn in for A, B, and C, and one in for not C as well. Now we're going to see when both B and not C are true. This set of values corresponds to the final term in the expression, which we're going to put together with the first two we solved for to get our final answer. Alright, now we have tables for A, B, C, and each of the expressions we solved for originally. Since the expression uses or signs or plus signs, we're going to see when each not A and not B and not C, or not B, not C, or B, not C is true. I'm just going to write or in the last column so it's easier to understand. Now, when there's a 1 in any of those three columns, the final expression is true. So that's the first place, the second place, the third, the fifth, and the seventh. These correspond to the following values for A, B, and C. However, since the question asks for how many different values correspond in a true result, we don't really care about A, B, or C. Again, there are 5 different values that make the expression true, so your final answer is 5.